Hi and welcome to Tech Tip Friday. I'm Kurt Stahle, that plastics guy, and you know what I'm doing. I'm bringing you a tech tip that you could take to the shop floor with you today. So a lot of what I try and do here is based on instances, cases, if you will, that I encounter with my customers just, on a day-by-day basis. So I had one of my favorite customers reach out to me on Monday asking about parts warping that he was running, and it's something that he's run for quite some time. Now, he was running the part in an unfilled polypropylene, and there really weren't heavy ribs to stop the part from warping. And he asked, well, what can I do? Would it go to a different melt flow of polypropylene? And the first thing I thought of, well, bins, crates, a crate grade polyethylene, about a 6.7 melt, and there's some very specific properties around a crate grade polyethylene, cold impact resistance. Think of your recycling bin out at the corner waiting to be picked up and some of the abuse those bins take. Well, that's crate grade. So that was my first thought. And this fellow had an 8 to 10 melt that he already had on the floor. And so well, go ahead and run that and see what happens. Now, some of you may be thinking, but Kurt, polyethylene warps just like polypropylene. Well, it depends. As anything in our industry, it always depends. Polypropylene, or sometimes jokingly referred to as polywarpylene, yes, it does warp post-mold. It will warp during the molding process, but post-mold in a high heat environment, it is actually a little bit better than polyethylene. And polyethylene, if you're not molding it carefully, you can have molded in stress there too. And after molding in the application, polyethylene would have less heat resistance than polypropylene. But for this application, it's not a part that would see an elevated temperature, during its life cycle. So let's focus on heat distortion, warping during molding. And there's a few things that you can do, and I think I'm going to talk about this over a couple of weeks. But the first thing that you really have to look at is, well, we're going to break it down to the first thing. First things first, the mold temperature. I'm going to make an assumption your screw and barrel is set to whatever material you're running. Check your data sheets, consult with the supplier if you have any questions. Now, doing the same thing for the mold, of course, look at your temperature. You may find, maybe inadvertently during a mold changeover, your setup crew didn't change the temperature of the water going into the mold. Maybe you've got something too cold circulating, water that's too cold circulating through the mold. And you may not want that given the geometry of the part. Remember, everything is part specific. So if you're seeing warping, one of the reasons for that can be a differential coolant temperature between core and cavity. So an easy way to assess that, if you don't want to trust, the cooling circuits or the water temperature that you've got coming into the actual mold itself, get one of those infrared thermometers. I think I picked one up from a local hardware store, up here, Canadian Tire, $30, $35 maybe, with a couple of batteries included. If you're, a fan of a certain red and black tool brand, yes, they do their own, and it's about $150. And chances are something like that, maybe it's better suited for an industrial environment. But if you want something on the quick and dirty, just go to Canadian Tire or the like of whatever you have close to you. Get one of these handheld infrared thermometers and scan a few positions on the tool, both core and cavity, and see if there's a big spread in temperature. You may find that the outside edges of the tool, where your part would come off, the outside edges, they may be significantly warmer or cooler depending on the cooling circuit. So you'd have a degree of molded in stress. You may find too that either the core or cavity has radically different temperatures, like I'm talking 15 or 20 degrees difference, which could create molded in stress. Now, if everything is reasonably close on temperature, core to cavity and around various spots in the tool, then you may want to try simply lowering the amount of coolant coming in to the tool, your fresh water or chilled water. if the part or if the tool is too cold and you're shocking it with hot material, that may create some built-in stress as well. I understand you want to increase your cycle time, but if you're running a fast cycle time and you're not running parts that are passing your customer's quality requirements, well, you're obviously not winning. So you've got to strike a balance and, you know, maybe just let the tool sit a little bit warmer and maybe add half a second on to your cooling time with the mold closed, and you get a flat part. And if that's the solution, well, start there and then see how much you can maybe optimize other aspects of your molding cycle to get that time back. So just a few thoughts for you. Get one of these infrared thermometers. They're not an expensive purchase, and they can save you a world of hurt and help you to understand the coolant cycle of your tools. So there's your tech tip. I hope you can take that to the floor right away. And as usual, do have an awesome Friday, fantastic weekend, and we'll see you back here next week. Thanks so much. Take care and bye for now.